Hey everyone, welcome to Code4fewbucks, where we make coding simple and fun. Today, we're going to build the classic Flappy Bird game using Python and Pygame. We'll break everything down step by step, so by the end of this tutorial, you'll have a fully working Flappy Bird game. First, you should download the assets folder for this game. The folder link is in the description. Download it and unzip it, and move it to the game folder. Okay, now, first install Pygame by using command pip install Pygame in terminal. I already installed it. Let's start by importing Pygame and setting up the game window size. Pygame is the library we'll use to create the game. OS helps us load images from our assets folder. .random is used for generating random pipe heights. Pygame.font.init initializes Pygame's font system for displaying the score. Let's define the game window size as 500 pixels wide and 800 pixels tall. Now let's load all the images needed for our game from the assets folder. I will fast forward this portion, but feel free to pause if you want to catch up. Okay, great. And now, Pygame ImageLoad loads the images, and Pygame Transform, scale to X, doubles their size for better visibility. Let's resize game. Overimage to 350 pixels so it doesn't cover the whole screen. First, let's create base class. Base is actually the floor that's going to be in the game. Let's declare variables first. This sets the speed at which the ground moves to the left. The higher the number, the faster it moves. And width gets the width of the ground image so we know how wide it is. And finally, let's store base image as image. Let's define constructor. Dunder. Init is going to take y as input, so let's assign it to self.y. Here the base always moves horizontally, so its y position stays fixed. We set its vertical position when creating an object. The first base image starts at xis equal to 0, so self.ex1 is 0, and self.x2 is going to be the width of our base image. In base class, there is going to be only two functions. One is move and another one is draw. In move function, let's make the base image to move continuously in the defined velocity. If self.x1 plus self.width lesser than 0, this checks if the first base image has completely moved off the screen. If it's true, move self.x1 to the right side of self.x2, creating a looping effect. Similarly, if self.x2 plus self.width lesser than 0, move self.x2 to the right side of self.x1, continuing the loop. Instead of resetting one image, we use two so that there's always another one visible, while the first moves out. Finally, draw method is to draw our base images in the game window, so it is going to take window as one variable. Window.blit self.image self.x1 self.y. This draws the first base image at self.x1, self.y. Similarly for other one, window.blit self.image, self.x2, self.y. Okay, that's all for base class. Now let's create a class for pipe. First, we define the class with class pipe. This is where we create the blueprint for the pipes that the bird has to avoid in the game. Next, we have gap. This sets the gap between the top and bottom pipes. The gap is 200 pixels, meaning there's 200 pixels of space for the bird to fly through. Then, velocity sets the speed of the pipes. This means the pipes will move 5 pixels to the left every frame. Now, we define the constructor. This is the method that's called when. We create a new pipe object, The X parameter represents the starting position of the pipe on the screen. Inside the constructor, we have self.x, which stores the horizontal position of the pipe. Then we have self.height, which is set to a random integer between 50 and 400. This is to generate a random height for the top pipe, anywhere between 50 and 400 pixels. We want the pipe's position to change each time for variety. Next, self.top is equal to self.height minus pipe image. .getHeight. This calculates the top position of the pipe. We subtract the height of the pipe image from the random height to position it properly. After that, let's set self.bottom to self.height plus self.gap. This calculates the bottom position of the pipe. We add the gap, which is 200 pixels, to the height to get the bottom pipe's position. Now, let's flip the pipe image vertically to create the top pipe. The false argument means we don't flip it horizontally, and true means we flip it vertically. And let's store the original pipe image for the bottom pipe without any flipping. We also set self.. Pass to false. This is a flag to track if the bird has passed the pipe. We'll use this later to increase the score when the bird successfully passes a pipe. Now, let's look at the move method. This method makes the pipe move to the left by subtracting self.velocity from self.x. This gives the effect of the pipe moving across the screen, and that's all for the move method. Next, in the draw method, we draw both the top and bottom pipes on the screen. Window.blit self.pipetop. Inside brackets, self.x, self.top draws the top pipe at the calculated position, and window.blit self.pipebottom. Inside brackets, self.x, self.bottom does the same for the bottom pipe. The off-screen method checks if the pipe has gone off the screen. It does this by checking if self.x plus pipe image dot get width is less than 0. If it is, the pipe is off-screen, and we return true. Finally, the collide method checks for collisions between the bird and the pipes. This method is responsible for checking if the bird has collided with a pipe. It takes in one parameter, bird, which is an instance of the bird class. First, we create a mask for the bird using birdMask equal to bird.getMask. This mask is a way of representing only the visible parts of the bird, ignoring transparent pixels. We use this because checking collisions using masks is more accurate than using simple rectangles. Next, we create masks for both the top and bottom pipes. Here, pygame.mask. From surface, inside brackets, self.pipe. Top takes the pipe, image, and creates a mask from it. This means it only considers the non-transparent pixels of the pipe when checking for collisions. We do the same for the bottom pipe. Now, we calculate the offsets. These offsets determine the position of the bird relative to the pipes. Self.x minus bird. .x gives us the horizontal difference between the pipe and the bird. Self.top minus round bird. .y gives us the vertical difference between the top pipe and the bird. Self.bottom minus round bird.y does the same for the bottom pipe. Now, why do we need these offsets? Because the masks are positioned relative to their objects. The bird mask is positioned at the bird's coordinates, and the top mask is positioned at the pipe's coordinates. To check for a collision, we need to know where the bird's mask overlaps the pipe's mask, so we use offsets to align them correctly. Next, we check if the bird's mask overlaps with either pipe's mask using overlap. The overlap function checks if there's any intersection between the two masks. If the bird's mask overlaps with either the top mask or bottom mask, it means the bird has hit a pipe, and we return true. If there's no overlap, we return false, meaning the bird has successfully passed through without colliding. Okay, that's all for Pipe class. It handles the creation, movement, drawing, and collision detection for the pipes in the game. Final class for this project is Bird class, which we are going to handle movement, jumping, tilting, animation, and collision detection for the bird in the game. First, let's define a class variable images and set it to bird images. This is a list of images used for animating the bird's flapping motion. Then, we have max rotation set to 25. This controls the maximum upward tilt of the bird when it jumps. Next, rot velocity is set to 20. This determines how fast the bird tilts downward when it starts falling. After that, animation time is set to 5. This means each frame of the bird's animation lasts for 5 game frames before. Switching to the next image, now let's define the constructor. This method is called when we create a new bird object. It takes in 2 parameters, x and y, which represent the starting position of the bird. Inside the constructor, we store these values by setting self.x to x and self.y to y. Next, self.tilt is set to 0. This will control the rotation of the bird. A positive tilt makes the bird point upwards, while a negative tilt makes it point downwards. Then, self.tick_count is set to 0. This keeps track of how many frames have passed since the bird last jumped. After that, self.velocity is set to 0. This represents the bird's current speed when moving up or down. Next, self.height is set to self.y. This stores the bird's initial height, which we use later to calculate movement. Then, self.image_count is set to 0. This tracks how many frames the bird has been using the current image. Finally, self.image is set to self.images at index 0. This means the bird starts with the first image in the animation sequence. Now, let's look at the jump method. This method is called when the player makes the bird jump. First, we set self.vel to -8. A negative velocity makes the bird move up since the y-axis increases downward in Pygame. Next, we reset self.tick_count to 0. This allows us to track how long it has been since the bird last jumped. Then, self.height is updated to self.y. This stores the bird's position at the moment it jumps so we can calculate movement later. Now, let's move on to the move method. This method updates the bird's position as it moves up and down. First, we increase self.tick_count by 1. This keeps track of how many frames have passed since the last jump. Next, we calculate d, which represents how much the bird should move. We use the formula of self.velocity times self.tick_count plus 1.5 times self.tick_count squared. This simulates gravity. At first, the bird moves up because velocity is negative. But as tick count increases, the bird starts falling because of the squared term. Then we check if d is greater than or equal to 16. If it is, we set it to 16 to prevent the bird from falling too fast. If d is negative, meaning the bird is moving up, we subtract 2 from it to make jumps feel smoother. Next, we update self.y by adding d. This moves the bird up or down on the screen. Now, let's handle tilting. If d is negative or if self.y is still above self.height plus 50, we set self.tilt to max rotation, which is 25. This tilts the bird upwards. Otherwise, if the bird is falling, we tilt it downward by subtracting rot velocity from self.tilt. However, we make sure self.tilt does not go below -90, so the bird does not rotate upside down. Now, let's move on to the draw method. This method handles the bird's animation and displays the correct image. First, we increase self.img count by 1. This tracks how long the bird has been using the current animation frame. Then, we cycle through the images in a flapping pattern. Self.image count is less than animation time. We show the first bird image. If it is less than animation time times 2, we switch to the second image. If it is less than animation time times 3, we switch to the third image. If it is less than animation time times 4, we switch back to the second image. If it reaches animation time times 4 plus 1, we reset it to the first image and start over. Now, if self.tilt is less than or equal to -80, meaning the bird is facing almost straight down, we stop the animation at the second image. This prevents the bird from flapping its wings when it's falling. Next, we rotate the image using Pygame.transform.rotate, passing in self.img and self.tilt. After rotating, we adjust the position so that the bird rotates around its center instead of shifting weirdly. Finally, we draw the rotated image onto the window at the correct position. Now, let's look at the getMask method. This method creates a mask from the bird image. We use pygame.mask, from surface inside brackets, self.image to generate a mask that only considers the visible parts of the bird and ignores transparent pixels. This mask is used for accurate collision detection with the pipes. Okay, great. That's all for classes. Now let's define draw. Window method step by step. It handles displaying the background, pipes, score, base, and bird on the game window. First, we call window.blit with background image at position 0, 0. This draws the background for the game. Next, we loop through pipes and call pipe.drawWindow for each pipe. This ensures that all pipes are displayed on the screen. Then, we create a score text using stat.font.render. passing an F score, :space score, 1, and the color white in RGB format, which is 255, 255, 255. This renders the current score as text. Next, we call window.blit with text at width, -10 minus text, dot get width, 10. This positions the score at the top right corner of the screen. Then we call base.drawWindow. This draws the base at the bottom of the screen. Next, we call bird.drawWindow. This ensures the bird is displayed on the screen. Finally, we call pygame.display.update. This refreshes the screen to show all the updated elements. Let's define the main method. It handles setting up the game, starting the game loop, and managing game events and states. First, we set the title of the game window using Pygame display set caption with the text Flappy Bird with code4fewbucks. This gives the game window a title. Next, we create an instance of the bird class at coordinates 230, 350. This represents the starting position of the bird. Then, we create an instance of the base class at y equals 730. This sets the initial position of the base, or ground. After that, we initialize the pipes list with a single pipe at x equals 700. This adds the first pipe to the game. We create the game window with dimensions, width equals 500 and height equals 800 using Pygame display set mode. We then create a clock object to control the frame rate of the game and set it to 30 frames per second using clocktick30. Next, we initialize the score variable to 0, keeping track of the player's score. We set the game started flag to false, which indicates whether the game has started or not. Now, we enter the game loop, where we continuously update the game state. First, we call base move to move the base to the left. We then handle events using a for loop and Pygame event get. If the event type is quit, we call Pygame quit to quit the game. If the event is a key down event with the space key pressed, we set game started equals true and call bird jump to make the bird jump. If the game has started, we call bird move to update the bird's position. Next, we loop through the pipes list and move each pipe by calling pipe move. We check for collisions between the pipes and the bird, using pipe collide bird. If a collision is detected, we call the game over function, which we will define later, to handle the game over scenario. If the pipe has passed the bird, that is, it has moved past the bird's X coordinate, we mark it as passed and increment the score by 1. If the pipe is off the screen, we remove it from the pipes list. If the last pipe in the list has moved past a certain point, we add a new pipe to the pipes list to keep the game going. Finally, we call the draw window method to update the display with the bird, pipes, base, and score. Let's define the game over function. This function handles the game over scenario when the player loses. First, we calculate the position to center the game over image on the screen. We do this by subtracting the width of the game over image from the width of the window and dividing by 2 to get the X coordinate. Similarly, we calculate the Y coordinate by subtracting the height of the game over image from the height of the window and dividing by 2. Next, we use the window.blit method to draw the game over image at the calculated X and Y coordinates, which displays the game over screen in the center of the window. Then, we update the display with Pygame display update to show the game over image. After that, we call Pygame time delay with a value of 3000 milliseconds, which pauses the game for 3 seconds before proceeding. Finally, we call the main function to restart the game, which will reset all the game elements and start a new round. Alright, that's all for the coding part. Now, let's run this thing. Perfect. Oh wait, the score is not working as we coded, or tried to code. And wow, that game over image. Let's just say it's not exactly professional. Aha, I see what's going on here. Let's review the code quickly. Oh, I totally forgot to assign the game over image after transforming it. Rookie mistake. And as for the score issue, let's see. Oh yeah, the issue is that I wrote pipe_past instead of pipe.past. Silly me. Now it should be working as expected. Yup! It's working. Score is updating, and the game over image is, well, slightly less horrendous. Progress. Alright, legends, that's all for today. We just made a Flappy Bird game in Python. Thanks for watching, and if you enjoyed this, consider liking and subscribing. It's free, and it helps me make more of this mess of a game. Cheers!